Welcome to EEGmaster.com, your go-to resource for learning EEGs. In this short video, we will be discussing Color Density Spectral Array, C.D.S.A, or also commonly referred to as Power Spectrogram or FFT spectrogram. It is a three-dimensional display of distribution of power across different frequencies over time. The time is plotted on x-axis, frequency on y-axis, and power on the z-axis using a colored scale. The black, blue, or cooler end of the color spectrum represents the low power, and white-pink colors represent the high end of the power spectrum. Since frequency is plotted on the y-axis, higher frequencies are represented by the color bands on the top and lower frequencies are represented towards the bottom of the spectrogram. In order to better conceptualize these spectrograms, one should understand that at a given time, the digital EEG tracing is a combination of different frequencies. The qEEG software analyzes this EEG signal using Fast-Fourier Transformation technique. It breaks EEG down in component frequencies, then calculates power for each of these frequencies. Power is amplitude squared for the component frequencies. In the example shown, the FFT spectrogram shows higher power for the slower frequencies in the right hemisphere. The white and pink colors in the right hemisphere spectrogram are not apparent on the left hemisphere spectrogram. Overall, for both hemispheres, higher power is seen for lower range frequencies, and relatively lower power is seen for higher frequencies. On the raw EEG, this patient had continuous generalized slowing, right-sided slowing, and higher amplitude on the right side due to a known skull defect. Notice that the spectrogram has a rather monotonous appearance. This correlates with a lack of reactivity and state changes on the raw EEG. In our next example, a higher power pink stereotypic signature, marked by red arrows, is intermittently seen on the spectrogram and is more prominent in right hemisphere. This signature corresponds to the seizures arising from the right hemisphere. Ictal signatures are usually stereotypic abrupt changes with ramp-up or ramp-down in power across different frequencies. These changes can have different morphologies or shapes such as flames and arches. A regular, stereotypic abrupt appearance with evolution and devolution in frequencies and amplitudes is key towards recognizing ictal signatures. Ictal signatures should be differentiated from the artifacts, which can also appear as an abrupt change. However, often have an irregular and more variable morphology, saturating all frequencies with a high power with no clear evolution or devolution pattern. In the example previously shown, the striped appearance of the spectrogram after the first seizure, marked by pink arrow, is usually reflective of a burst suppression pattern, which in this case appeared after administration of a benzodiazepine. Lastly, a predominantly cyan blue spectrogram like the one shown in this picture typically represents a completely suppressed EEG.